Okay. Lesson 7.5 is what we're doing today. And you will notice that we already went through and filled in these powers. So we kind of talked about 2 squared is doing 2 times 2 and getting 4. 2 to the third means we're doing 2 times 2 times 2 to gain 8. So we went ahead and filled all these numbers in, and we filled these in. We're going to use them as we work in our lesson a little bit. Okay, so Lily, if you are watching this video, I would say pause and get those all filled in. Okay, and then continue. So I forgot to start the recording. Or anyone else watching the video. I don't know.
I don't think Cameron. No, I should put them to YouTube. Huh? Should put them to YouTube. Really? You upload them to YouTube?
Well, I upload them to YouTube and then I use an embedded link and put it in Schoology. But it's actually a YouTube video. It makes it actually a YouTube video. So.
I don't think you probably thought that. Like, let's say someone else is having problems with it, they could find the video on YouTube and boom.
Except that my videos aren't listed. I mean, I just titled this video lesson 7.5. Anyway, no one can really randomly search YouTube and, they don't need lesson 7.5. They might need rational exponents, but. Okay, guys, let's focus here. We're not very focused. Okay, so we are talking about rational exponents and radicals today. So first of all, when we talk radicals, I'm talking like the square root looking things, right? If it's a square root, there's no number right there in the little corner, is there? Do you know what the invisible number is if it's a square root? Invisible what?
I'd assume 1.
Not 1, actually.
Yeah, I was gonna say, I'd assume that because we use them.
Okay, it's a square root, so it's an invisible 2. Okay? If we're doing a cube root, there is a 3 there on the edge of the radical. If we're doing a 4th root, there's a 4, a 5 for a 5th root, so on and so forth, right? Well, what we're going to work with, one of the things we're going to work with is being able to go back and forth. To do the square root of x, that can also be written as x to the power of 1/2. So taking this little number here that's in your radical and writing it as the denominator. So the cube root of x is x to the 1/3. Cube root of x, 4th root of x is x to the 1/4. 5th root of x, x to the 1/5. If you saw an 8 in here, it'd be the 8th root of x. Okay? So you need to be familiar with that. We'll talk about it more as we go. Let's look at this example right here. Cube root of 27. Thoughts and ideas of how to find the cube root of 27. Put the iPad away right now, Robbie, okay? Lay it down so you're not tempted to mess with it. Okay? So we can think of this as 27 to the 1/3. But that's not really, I'd rather you just think, what is the cube root of 27? I think you'll have a little more luck there. So cube root means how many of something have to multiply together? Well, 3 times 9 is 27, but I'm looking for what number times itself again gives me 27. What number times itself again gives me 27? Now, 9 times 9 is 81, which is already bigger than that. And times another 9 would be way too big.
It's 3.
Okay, so what do you know? 3 times 3 is 9. Times 3 is 27. I just totally started to write 27 instead of 3. Oof, you can tell it's the end of the day, right? So the cube root of 27 is 3. There's other ways we could write that too, but as far as I'm concerned, that works there. Okay, now let's try the next one. 5th root of 32. So some number times itself, times itself, times itself, times itself equals 32. So that means you multiply 5 of the same number together and get 32.
Oh my God.
How'd you find that it's 2?
I don't know. I was just plugging in numbers at the same time.
You guessed and checked, right? I'm with you. Okay, so here, I put my calculator up here. 5 times 5. Nope. Try again. 2 times 2 times 2 times 2 times 2. I have 5 2's up there. And when I multiply them, I get 32. So what is the fifth root of 32? 2. And that's because this is 2 to the 5th, isn't it? You're doing the fifth root of 2 to the 5th. Now, had we talked about 32 already today?
No.
Had we used the number 32?
Yeah, on that.
Yeah, was it in that page?
And it was like,
Yeah. 2 to the 5th is 32.
we should have got that right.
So the fifth root of 32 is 2. 27.
Yeah, that was good.
The cube root of 27. 3 to the 3rd. Now, do you see, there's a reason I had you fill that out, right? Okay. What about the cube root of 64? I need 3 things that multiply to be 64. And here's my thought. Where's 64 on this paper? 4 to the 3rd, yes? So 4 times 4 is 16. Times 4 is 64. So the idea here that 64 is 4 to the 3rd. What's the cube root of 64?
4.
It is 4. Okay. What about the square root of 36?
Pretty sure that's
Hello? Yes, you can. You're welcome. Guidance office. Okay. Square root of 36. Do you know it?
Yeah.
6.
Yeah.
Because what number times itself is 36, right? It's easier when you only need 2 of them. And the idea, it's the square root of 36. So it's the square root of 6 squared. So as I've written these, you can kind of see, okay, cube root of 64 is cube root of 4 to the 3rd. Those 3's basically cancel each other out, and you have an answer of 4. Okay. Now, calculator. Oh, and Robbie just left, didn't he? Okay, well, you have my calculator. You have a different calculator. So, which is fine. On these calculators, you can actually do this math too. So, if I wanted to do, let's go back and do the fifth root of 32. I want to do the fifth root. So on this calculator, we'll figure out yours, McKiley. I'm going to do 5 because I'm going to do the fifth root. And then if you look right here above my exponent, my caret sign, there's an x and a square root sign, right?
Yeah.
If I do that x and square root sign, this is saying I'm going to do the fifth root of whatever I type next. I want the fifth root of what? 32. We already said the fifth root of 32 is 2. Guess what? It works. Okay. Michaela, your calculator would have that option 2 somewhere.
Yeah.
Yours is right here. So if we do 5.
Oh.
There you go.
I never knew how to
There you
get
go.
the second little symbol to work.
Yeah, when you have a blue symbol on yours, so the symbol above the button, so you do second and then that.
Thank you.
You're
I
welcome.
never knew that.
Glad it could be helpful there. Did you figure it out, Jacob?
No.
Maybe he needs to know the information about second. I just assumed that was known information.
No,
So then
I've
if you
been
do
trying to figure it out
second,
for 2 years.
this will do whatever's above the button. Okay, except you hit the wrong one. We wanted the one there. Because this is going to do 5 times the square root. So clear? Or yeah. So 5. And then you want that one right there. Because now that little x says, okay, that 5 is in that spot of that x. Okay. I taught something new on the calculator. There we go. Okay. Now, we're going to put this together with the idea of, if you glance down below, the ones we did at top were all just, okay, the cube root is rewritten as x to the 1/3. The fourth root, x to the 1/4. The fifth root, x to the 1/5, right? Well, if there's a number other than 1 on top. And so, just kind of some basic rules here. First of all, the nth root of x can be rewritten as x to the 1/n. So if there's an n right here in the, what's it called? Index is what that spot's called. But that little radical spot, that goes in the denominator, right? Now, if it's the nth root of x to the m, realize that can be written as x to the m over n, because that little number in the index spot, the radical spot, is the denominator. X to the m, that m is going to stay on top. And so the nth root of x to the m can be rewritten as such. Okay? And that's what we're going to work with. So, number examples. The fourth root of x is x to the 1/4, 4 in the denominator. This one, the cube root of x to the second, so the difference is there's an exponent here under the radical, is x to the 2/3. So x to the power of 2/3. 3 is in the radical, so it goes in the denominator. 2 is a power, it's the numerator. So we're really just doing some work with going back and forth here. So let's look at this next row of examples, because I know you guys will do better with examples than me just trying to explain something. Okay. So convert to radical form. Basically, we want to take a to the 5/6 and write it with a radical. Okay? So, what's the main thing under the radical? My base is in a. So it's going to be a under the radical. Now, 5/6. One of those numbers goes right here on the corner of the radical, and the other number is the power of a. Okay? Denominator is always going to be which one? Well, the denominator is a 6, and where's it always going to go? Yeah, it goes right there on the edge of the radical. So this is saying it's going to be the 6th root of a to what power? My number in the numerator, so in the top, goes on the a. So the 6th root of a to the 5th. And that's all you're being asked to do right there. It just said to write it in radical form. Okay. That is radical form. Okay? Questions on how I did that? A to the 5/6, so 6th root of a to the 5th. Let's try the next example. 5x to the 2/3. So my question is going to be, what is the main thing that goes under the radical? Just x?
No.
I'd go back to the other answer. Why would it be?
X to the second.
We'll talk about the 2/3 here in a moment. But why is it only the x that goes under there? Why doesn't the 5 go under there?
Well, I'd like to be in your class. Because they put, because I didn't pass first semester, but they put me in here first, so they switched me.
I didn't either, but I'm in both of
They got me all confused.
Okay, well, for right now, sit right here.
Yeah.
Unless they told you to go somewhere else. But
No, he told me to stop by back in tomorrow.
It's just 3 of us in here now.
Technically 2, because Lois is still there.
Oh, yeah.
well, but
It's so
I don't know.
strange.
I don't like that.
I don't know. We'll worry about it tomorrow. I find it strange that they're switching you now
Yeah.
when I understand why in a way, but I don't know. Whatever.
It's just gonna screw me up.
Well, because now you're going to be jumping into. So are you going to Mrs. Rogers' class?
What are you gonna do next
Okay.
time? What is that?
What is this hour? It's my resource.
Okay. Okay. 5x to the 2/3.
Yeah.
So x is going under the radical.
Mm-hmm.
What's that mean about this 5?
I don't know. What do I do with that?
Okay. It. What were you going to say?
I thought that we were going to put it like on the top of the radical. That'd be wrong.
No. It's just going to go out front of the radical. Because it doesn't have a power, we're just going to put the 5 out front. It's going to be 5 times whatever this radical is. Now, what kind of radical? What goes where? 2, 3, 3, 2.
Oh, the 3 goes to the little thing outside.
Okay.
And the 2 goes on the
Okay. I agree. So this is 5 times the cube root of x to the second. For the third root, 3 goes there because it's in the denominator, 2 goes there because it's in the power. And that's all we're doing. We're just leaving it like that. Okay. 16y raised to the 1/4.
Okay.
So here's my radical. What goes under my radical?
The y. Is it 16y? It's all in parentheses.
It's all in parentheses, right? That 16y all has the power of 1/4, so it's going to be 16y under the radical.
To the first.
Okay. The power is the first, so I don't have to write that. What's the index or the number that goes right here on the edge of the radical? The 4. So we have the 4th root of 16y. Now, I'm going to tell you, we want to go one step farther on this problem. In that, if there is something under the radical we can simplify, we should do that. So that pretty much makes you ask, can we do the 4th root of 16?
Yeah.
What is the 4th root of 16? Yep, look back to that paper.
4. I know the 2.
2, right? The square root of 16 is 4.
Yeah.
But if you look back on that other side, 2 to the 4th was equal to 16, wasn't it? So the 4th root of 16 is 2. That 2 is now going to be out front of the radical. And then, can we take the 4th root of y? We can't. So it's going to stay the 4th root of y. So I have 2 times the 4th root of y.
Oh, yeah.
Okay? Okay, let's try the next row. Okay, now we're doing the opposite. They're giving it to us in radical form. We want to write it in exponential form. So right now it's the cube root of m to the second. This is m to what power?
Down to the second. Oh, wait. No, it's into the 2 over 3. I don't know what I'm talking about.
You might know what you're talking about. What do you think, Jacob?
I think that we. That's it. Multiplying it. No. I don't know.
No, we're doing, so if you look right here,
2 or 2 or 3.
here it was a to the 5/6. We wrote it as the 6th root of a to the 5th. Now it's the cube root of m to the second. So we're going to write it as m to, you got 2 options. 2 over 3 or 3 over 2.
2 over 3.
2 over 3. It is. I didn't say you were wrong. Okay. I was trying to make Jacob think here. He was starting to space out on me. But that 3 in the radical is my denominator. 2 is the numerator because it's the power. And that's all you have to do on that one. We're just trying to get the basics of going back and forth here. That's all I'm trying to get you guys to do. Now this next one. 12 times the cube root of x to the 4th. That 12 is already it's its own little thing. Good answer. It's just going to be out front. And then we're going to have x to 3/4.
Yeah.
Jacob, do you agree or disagree with her?
Wait, no. 4/3.
4/3?
Yes.
I only disagree though because after you said my name, usually when they bring it up.
I brought it up last time though and she was right.
Yeah, I just had to question myself.
That time it was worth the question though. Okay, so do we understand 4/3? The power is 4, so it goes on top.
Yeah.
That index, the radical is 3, so it goes on bottom.
Well, I just glanced at it and I just figured because the 3 was smaller.
3 was bigger here though and went on bottom. So, okay, next one. 4th root of 256 a to the 8th. And what you might want to do on this one, and I guess because I know something here, is think, what is the 4th root of 256 and what is the 4th root of a to the 8th?
Yeah.
Because if you think of it as two separate things, that might help you. 4th root of 256. Is there a number times itself, times itself, times itself?
Four.
Is it on the paper? I was trying to remember. I was like, is it on the other side? Okay. So if you look on the other side, 4 to the 4th was 256, wasn't it? So if 4 to the 4th equals 256, then the 4th root of 256 is 4. A to what power?
8/4.
I think I've heard both answers now. Which one? 4/8 or 8/4? Little number, this number right here always goes on bottom, so 8/4.
Yeah.
What do you know about 8/4?
It is 1/2.
Disagree?
It's because it's upside down and proper.
Oh, no. Oh my god, no. What am I thinking?
If it was 4/8, I'd go for your 1/2.
Yeah.
But it's 8/4, so I need to hear,
It is improper.
right? But what is 8 divided by 4? 2. So this is 4a to the second. Okay, one more. The 4th root of 16y to the 3rd. Does it help if I make you think 4th root of 16 times 4th root of y to the 3rd?
Okay. 16y to the 3/4. Right?
Half, right? I like y to the 3/4.
Oh yeah, I gotta deal with the 16.
Mm-hmm. What is the 4th root of 16?
2.
2. So 2y to the 3/4. And that one doesn't reduce any further. Okay. You guys have a little bit of work to do in Math Excel you can get working on.
Because I greatly appreciate